Experts are certain that we will divide the era of space exploration into a time before and a time after the James Webb Telescope. This is hardly surprising, given that the discoveries made by the most powerful telescope of all time have already shown us that our current models simply do not match cosmic reality as a whole. A range of structures that, according to our understanding, should not exist at all in this form has already been discovered by Webb. Specifically, these refer to things that formed immediately after the so-called Dark Age, and which simply appear much too large and massive for their early formation time. As a result, experts are increasingly admitting that our established ideas about the early universe are hopelessly outdated and that there is still a long way to go before we fully understand this confusing era. Of the thousands and thousands of objects that sparkle at us on starry nights, it seems inconceivable, and yet, the universe was once a place of total darkness. Indeed, the universe has undergone numerous changes since its inception 13.8 billion years ago. In the first 380,000 years after its creation, the universe was initially a hot and dense ionized plasma, but it later cooled down to such an extent that the protons and electrons filling the universe were able to combine to form neutral hydrogen atoms during the so-called Dark Age. However, there were no light sources, no galaxies or stars, just a transparent, neutral space filled with a dense fog of hydrogen gas. The cosmic light was turned back on during the time that followed, thanks to the first stars and galaxies, which emerged about 100 million years later and gradually reionized the gas through their ultraviolet radiation. In the course of this, the electrons were separated from the protons, leaving them as free particles. Among experts, this era is known as the cosmological twilight. Although it is still surrounded by some huge question marks, the James Webb Telescope has already shown us that it performed very differently than previously thought. There is one thing we must not forget. Webb was specially developed for infrared astronomy, and one of the main tasks of the $10 billion device is to investigate the farthest and thus oldest corners of the cosmos, catching a direct glimpse into the immediate phase after the Dark Age. The results are quite astounding. If you are even a little bit interested in this matter, you will have heard that Webb detected 6 early galaxies as early as 2023, which are nothing short of an astronomical impossibility. More specifically, these findings refer to the fact that these galaxies were already in place 500 to 700 million years after the Big Bang. Despite this, they were already as massive as our Milky Way is today. Accordingly, all 6 galactic premature babies contain more than 10, and in one case, even more than 100 billion solar masses of stars. To explain the existence of such massive galaxies at this early stage, either the density of matter in the young cosmos would have to be 2 to 5 times greater than predicted by the standard cosmological model, or the galaxies would have to have grown in a way that is completely unknown to us. In view of this, it's probably not particularly surprising that these galactic mysteries evolved into what are now known as universe breakers. But in truth, this was only the prelude to a series of even more baffling discoveries made on the internet that have since given scientists a severe headache. On the one hand, there is the galaxy named Jades, GS, Z140, which entered the cosmic stage as early as 290 million years after the Big Bang, and also presents itself as much too large and starry for that era. How a galaxy could have formed several hundred million solar masses of stars in less than 300 million years is an open question. It's important to think about this fact again. Before the James Webb Telescope revealed the true face of the young universe, experts assumed that there were only tiny, low-mass baby galaxies at that time. Theoretically, this makes sense. After all, our models suggest that so shortly after the Big Bang, there simply wasn't enough normal matter to form so many stars in such a short time. And yet, there they are, just like the red monsters that were detected a few weeks ago, and once again challenge our understanding of early galaxy growth. Is the standard model of cosmology wrong? In light of the constant stream of new surprises that the universe now reveals with increasing regularity, a fundamental question arises. If so many structures are found that blatantly contradict the standard model of cosmology, could it be that this model is simply wrong? To find out for sure, a group of researchers led by Meng and Xia from the University of Geneva set out to systematically search for early outlier galaxies once again. In the course of their work, the scientists evaluated data collected by Webb's near-infrared spectrometer, NIRCam, and they actually discovered 36 more massive, dust-enveloped galaxies that existed around 1 billion years after the Big Bang. Ultimately, Webb's high-resolution spectra penetrated the dust veils that made these galaxies nearly unnoticeable in the optical spectrum. As a result, the team analyzed the corresponding stellar mass and its relationship between dark matter and normal matter. Throughout this, 3 objects stood out clearly from the galactic mass. Due to their incredible size and red color, they were dubbed the Red Monsters by astronomers. In fact, the members of this trio are similar in size to the Milky Way, and they also present themselves as extremely prolific star formers. Expressed in figures, this means that their respective star formation rates amount to 795 to 1,300 solar masses per year, only further deepening the already existing mystery. To produce so many celestial bodies in such a short time, the 3 red monsters had to convert much more gas into stars than usual. Researchers state that their so-called conversion rate is between 2 and 3 times higher than what would be usual for the most efficient star formation in younger galaxies. Normally, such galactic youngsters can only use around 20% of the available gas for star formation. But the red monsters have apparently managed to circumvent the numerous processes that usually limit star formation efficiency. What does this discovery mean? For the standard model, this discovery provides encouraging news. There is no need to explain an impossibly high density of matter in the young universe. However, at the same time, the red monsters suggest that star formation and galaxy growth occurred in a very different manner back then than they do today. According to Xia and her co-workers, these findings supply potent evidence that the cosmos was 2 to 3 times more efficient in terms of galaxy growth in its early days. However, what enabled this remains completely uncertain. What is certain, however, is that the red monsters mark the beginning of a new era in the study of the early universe. Not only does the cosmic past now appear vastly different, but even our understanding of the present is becoming increasingly confusing. Webb shows that the universe is expanding too fast. As we all know, the universe has been expanding at a steady rate since the Big Bang, and at an ever-increasing rate. To explain this accelerated expansion, experts have predicted the existence of dark energy, which is thought to act as a kind of opposing force to gravity. Apart from this, however, practically nothing is known about it. The exact rate at which the universe is currently expanding is hotly debated. The standard model predicts a Hubble constant of around 67 kilometers per second per megaparsec, MPC. To put this in context, 1 MPC is about 3.26 million light-years. In other words, the speed at which galaxies are moving away from each other in space increases by 67 kilometers per second every 3.26 million light-years. However, real space observations, based on supernovae, gravitational lenses, and variable stars, have shown that the actual value of the Hubble constant is 73 kilometers per second per MPC. To be clear, this discrepancy amounts to a staggering 20,000 kilometers per hour per MPC. Could this be the result of measurement errors? That's precisely what Adam Rees's team at Johns Hopkins University in Baltimore sought to determine when they used Webb to re-examine data previously collected by the Hubble Space Telescope. The bottom line? The universe simply does not behave as it should in theory. Webb's observations confirmed a Hubble constant of 72.6 kilometers per second per MPC. According to Rees, everything points to the fact that our understanding of the cosmos is simply incomplete. We may have omitted a key component that contributed to the early universe's unexpected boost after the Big Bang, or dark energy may have unknown properties. There may even be exotic particles lying dormant out there that could help resolve this issue.